Okay, let's recap a very important topic in this module, which is how to write equations. Okay, there's two types of equations, explicit and recursive. And the difference is explicit equations use the first term, okay, to make a pattern to get to all the other terms. Whereas recursive equations, okay, they use the previous term. Okay, and let's show you what that's going to look like. Okay, so for explicit, I can make an arithmetic one. And that's going to be f of x equals, okay, you take your starting number, and then it's plus or minus the common difference times by x. But the x might have plus or minus depending on the starting number. For geometric, it's very similar. F of x equals, you have your starting number, okay, but now we're going to multiply by the common ratio, okay, and then it's to the exponent of x, and it might be plus or minus number. Okay, so that's how you do explicit equations. Now when you do recursive equations, it's going to be f of x equals previous. So you start with f of x minus 1. Okay, now if it's arithmetic, after you take the previous, arithmetic patterns are add or subtract the common difference. And if you're geometric, what you do is you take the previous, okay, but then you multiply by the common ratio. Okay, now for both arithmetic and geometric, they have to get you started, okay? So you always have to include f of 1 equals starting value. Okay, let's go over how to do this a little bit. Okay, so the first couple here are recursive. Okay, so recursive uses the previous. So what we're going to do here, I'm going to call my function f of n. So f of n says you take the previous. Okay, so I take the previous and then I do something. Take the previous and then do something. So what's happening here? It looks like the numbers are going down by 7. Okay, so the pattern, the common difference there is subtract 7. Now what about the first term though? Well, we have to get people started, okay? So I'm going to use this first term right here, which happens to be 3. So f of 3, the first one, is 42. Okay? Recursive, you use the previous and you really describe the pattern. Okay, I'm going to call this equation g of x. So how do you make a g of x equation? Well, we're going to take the previous, g of x minus 1. I take the previous and then I do something. Take the previous and do something. I think coming down here sometimes it's a little more obvious. It looks like the numbers are going down, but not by subtraction. It looks like they're getting divided by 5. Divide by 5, I'm going to write as 1/5. Let's go up here and check. Is 1,000 divided by 5 200? Yes. Okay, so this is geometric, and it has a common ratio of multiply by 1/5. That's what you do. Previous times 1/5. Previous times 1/5. That's how you get the rest of the table. Now don't forget, we have to get people started. So the first term in this table, g of 2, is 1,000. Okay, so the main idea with recursive is what's happening to each term. What's the pattern? All right, the last one, I'm going to call this the h of n equation. H of n equals, take the previous, which we'll call h of n minus 1. Okay, take the previous and then do something. Take the previous and do something. It looks like they're getting bigger, and it's not add. It looks like it's multiply by 4. 8 times 4, yes, makes 32. Okay, so take the previous and then multiply by 4. So I'm going to say previous, okay, multiply by 4. That's the pattern. Recursive really tells you the pattern. But remember, we got to start people off. Okay, so the first term here, h of negative 5, gives you a 2. You got to tell people the first one so they can make the pattern for the rest of the table. Okay, let's talk about explicit equations. Explicit equations are equations that can help you find any term using a pattern. Okay? And they tell us here to write the equation C of D. That makes sense because D could be the input variable and the cost would be C of D. So the C of D equation, okay, we're going to start with the starting value, which is 15. 15. Now what's happening to the table? Looks like it's going up. It's going up. It looks like the pattern here is add 10 each time. Add 10. So I'm going to say add 10. But it's not just add 10 one time. How many times do we do that? Okay, you always have to put your input variable, which is D. Now, since this table did not start at 0, I have to get D back to 0. So I'm going to have to subtract a 1. All right, let's take a look at another one. We are going to call this M of W, which makes sense because the weeks could be W, and then the miles are of W. So the M of W equation, the explicit equation, okay, starts with a value of 1. Start with 1. Now what's the pattern here? The pattern each time is multiply by 2. Multiply by 2. So I'm going to say 1 times 2. But you don't just say times 2. Okay, because look, it's times 2, times 2, times 2. How many times do we multiply by 2? Okay, we use our input variable, W. Okay, but the table did not start at 0. When it doesn't start at 0, you got to bring it back to 0. So we'll say W minus 1. Okay, when you're doing explicit equations, you don't have to state the starting value because we can calculate it using the formula. Okay, our last one right here. S of n. That's kind of weird. Why are they calling it S of n? I would probably call this D for days, and then S of D. Let's change this to S of D. That makes more sense for our problem. Okay, so the starting number is 10. So the equation is going to start with a 10. The pattern here looks like we are adding 5 each time. So we're going to say plus 5. Now, how many times do you add 5? Okay, how many times do we do that? You use your input variable D. Now let's go check the table. Since the table started at 0, it's the short version. That's all we have to do is just write the D. Okay, I really want you to practice writing equations. It's a very important topic.